Kia ora koutou katoa. Thank you so much for this opportunity to share this research with you today. Looking at the dual Far UVC and blue LED light. Just like to introduce my team back in New Zealand. Some of you might not know where New Zealand is. We're right down here at the bottom of the world. Also like to call it Middle Earth. And our team, Food Safety Systems Integrity team, is here in Palmerston North at the lower end of the North Island. Lovely scenery, encourage you all to come and visit us there. So there's two projects that I'd like to talk to you about today. The first is the COVID-19 Innovation Acceleration Fund, and this kind of kicked off our research with Far UVC. This was funded by the Ministry of Business, Innovation and Employment. And it was around deploying quickly services and products that were going to help in the fight against COVID-19. And then the second project is an internally funded one. We wanted to ask the question, is light the answer to antimicrobial resistance? So we looked at the inactivation of E. coli, multi-drug resistant E. coli, and then whether sublethal doses had any impact on the antibiotic susceptibility of those E. coli. So looking at our technology that we developed in the COVID-19 project, we had 3 units that we developed, BioLetto 1, 2 and 3. They all had the blue LED modules at 405 nanometers, and then they were coupled with a different UVC module. So we had the 265 nanometer UVC LEDs, we had the 222 Far UVC Exmalance, and then we had the traditional 254. So I'm only going to talk about BioLetto 2, which is the Far UVC and the blue, but happy to discuss the other UVC as well. So let's have a look at the first project. So we wanted to look at the inactivation of SARS-CoV-2. We wanted to do this safely in our lab. So we used a surrogate virus. So in this case, we use feline infectious peritonitis virus. This is a virulent pathotype of feline coronavirus. You can grow up to a really high titer, and it has really clear cytopathic effect, CPE, which you can see in the top right-hand corner there. In picture B, we used a saliva model, and then we took the virus and we put that onto 3 different types of surfaces, so metal, plastic and paper. We spotted it on and we dried it, or we kept it wet. And the graphs there just show the recovery that we got off of those discs was nice and high, so that we could see a clear effect when we added in the light. So we put the plates under the light at 25 centimeters, or just under 10 inches, I think, for most of you that go in inches. And this is what we found. So on metal, plastic and paper, overall, dual light was more effective than the individual Far UVC and blue LED light. We found for dual, between 4 to 16 minutes, we were able to get a virucidal effect, so at least a 4-log reduction in our virus. Metal, we found, was always quicker in the inactivation as compared to paper and plastic. As been pointed out before, obviously you have reflection and also a thermodynamic effect with heat that's going to happen in the inactivation of the virus. Dried virus was a lot harder to inactivate as compared to wet, and yeah, lots of stuff on there. So our second project, looking at the antibiotic resistant E. coli. So we actually had 4 E. coli strains that we looked at, 5151 and 6128. The antibiotic resistant E. coli that we isolated from natural waterways in New Zealand. And then we had the 460 and 4318, which are antibiotic sensitive E. coli. And these were our control E. coli. So we took the alveolytic culture and resuspended that in 500 microliters of PBS, and then placed that into a 24-well plate, and then back under our light at 25 centimetres. So our lights were equipped to shelves that we could slide into an old tissue culture incubator that we'd blacked out, which was really handy. And what we found was a synergistic effect. With virus, we saw an additive effect where the Far UVC and blue LED light, when you combined the log reduction, it came out at the same as what you would get with Joule. But with bacteria, we found that the blue light improved the efficacy of Far UVC light. So we wanted to see whether sublethal light doses were going to have any effect on these E. coli strains. So we exposed the 4 strains to 8 long pulses of 5 minutes of light, then 5 minutes off, 5 minutes of light. We did that 8 times. And what we found was that the antibiotic resistant E. coli became light tolerant, and the antibiotic sensitive E. coli did not. We then subjected those 4 strains to antibiotic susceptibility tests and found that there was no difference across these 6 antibiotics between the control, which is in black, and the treated in grey. And we found that for any of our treated E. coli, that they didn't change in their antibiotic susceptibility. So they remained resistant, or they remain sensitive. Finally, we wanted to see whether the light tolerance was passed on to subsequent generations after passage. So we passaged one of the light tolerant strains, the 5151, up to 5 times, and then subjected it again to Far UVC. Or Joule, and found that that light tolerance was maintained across the subsequent generations. So just in conclusions, Joule, Far UVC and blue LED light was virucidal against FIPV in solution and on various surfaces, even in the presence of saliva. The Joule light was bactericidal against our antibiotic resistant E. coli and our sensitive E. coli in solution. The light tolerance was observed in the antibiotic resistant strains, but not the antibiotic sensitive strains after those long pulses of Joule and Far UVC light. The antibiotic susceptibility profiles did not change with either the high or low doses, and the light tolerance was carried over onto subsequent generations. So just some of our future work. We want to do short and long rig sequencing of our light tolerant strains, so we can have a look to see whether any of these changes are genetic. We would like to do whole room disinfection scenarios with the dual light technology. We're just about to kick off a new project with China, the Catalyst project, where we're looking at advancing non-thermal sanitisation for infant milk production, in particular with Chronobacter sakisaki. And then we also want to look at what's happening with bacteria and bacterial spores as an omics approach with blue and Far UVC. So just want to thank my team back in New Zealand and other people who have helped with the projects. Thank you.
Thank you, Amanda. Time for a couple of questions, if there's any.
Unity, Dundee. I'll ask 2 quick questions, if that's okay. One is, what's the kill mechanism for the blue light? And then the second one is it worrying that you saw resistance in the E. coli's over quite a short space of time?
Okay, so the blue light has a different mechanism to Far UVC and traditional UVC. So that is creating radioactive species, generating this energy state, which then can impact on the cell membrane and other components of the cell. So we believe with the synergistic relationship that is what's happening is it comes in and maybe destroys the cell and then allows this penetration of far UVC to come through, which aids in a better inactivation. And what was your second question? Sorry.
Is it worrying, the resistance that you saw?
Is it warning?
What worrying?
Oh, worrying. Yes. So that's probably a key takeaway from this is that we did see that light tolerance, especially with antimicrobial resistance being such a large issue globally. So you really need to think about how you are going to apply this in a larger way. And if you're going to use low doses, is this going to create more problems going forward?
Yes, I have two questions. Did I see that right, that you applied about 280 millijoule per square centimeter of Far UVC?
So that would have been with the blue light combination, I think.
And also you showed for a very brief moment radiant flux measurements or what you applied. Could you bring that up again?
Yep. I've been a bit quick. Oh.
Okay, maybe not. Maybe we can talk later.
Yeah. Oh, lots of questions.
Is the blue light at 405, I'd call it violet, special, or what happens if you go to blue at 450? Any thoughts, or you only did the one?
We've only really looked at 405 with our research. I think there is some research out there at 450. But yeah, not something that I've looked into, sorry.
Thank you for these really interesting results. Could you comment on the combination between the 405 and the 254?
So yes, we didn't see any impact with the blue with the 254. So, excuse me, 254 on its own was very effective. And we found that we could inactivate the virus within about a minute. It was very quick. So the blue didn't aid in any way. Same with 265 as well. Yeah.
Okay, I don't see any more questions. Let's thank our speaker.
Thanks.
Thank you.